This is section 3, response formats. In this section, we're going to look at how to encode and decode JSON, how to work with XML, how to write gRPC applications, and how to work with protocol buffers. This is video 1, working with JSON. In this video, we're going to take a look at how to encode and decode JSON, how to use JSON annotations to have more control when encoding and decoding. So what is JSON? JSON, or JavaScript Object Notation, is a lightweight data interchange format. JSON is very easy for humans to read and write, and also for machines to parse and generate. Currently, it is the most common format for using REST services. So let's look at the basics of encoding and decoding JSON. To that, we're going to open the folder example 1 on the video 1 of section 3 of the course repository. There are two functions that we should be looking at. The first one is Marshal. Marshal takes an element and transforms it into a JSON formatted slice of bytes. It takes an empty interface as parameter, and it returns a slice of byte. So we're going to marshal and a slice of ends, and then we're going to print it. To print it, we need to transform the slice of bytes into a string. The other basic function is a marshal, which takes a JSON formatted slice of bytes and returns an element. An element could be a Go struct, a map, a primitive, etc. In this case, we're marshaling the example 1, the one we got, and we are assigning it to this element that is a slice of bytes. We'll see all of this in more detail later. Then, since it's a slice of byte, we want to print the first element. So let's try this. We are on section 3, video 1, example 1. As we see, this is a JSON representation of a slice of bytes, and then we unmarshal it, and we got the element on index 1 of the array. Let's look at example 2. On example 2, we have more things that we are marshaling. First, we will start marshaling some primitives, a boolean, an integer, a float, and a string. We're going to print the string representation of that JSON string. We're also going to be marshaling some slices, and a slice and a map, and a slice and a map, and then a couple of structs. These are struct literals. This is the first struct. We see it has a lot of different things. And then we have another struct, and then we have a struct that also has a substruct. Okay, so let's print this. We are in example 2. Well, first we got the boolean value. This is a JSON representation of a boolean value. This is an integer, this is a float, and this is a string. A slice of elements is represented like this. Then we had a map. Notice that the map added quotes to all the keys of the map. Then we have the first struct. It also adds quotes to the name of the struct elements. Let's look at that again. This is a struct 1. We have A, B, C, and D. C is a map. And let's see how we have 99 for A, hello B for B. The following a slash. The following is slice for C, and this map for D. Let's see how this was printed. It was printed as A99, B hello B, C, which is a slice of a string, is represented like this, and D, which is a map, is represented like this. Notice how maps and structs are actually represented in the same way, as this will be the key of the map, and this is the value of the map. And in this example, this is an element of the struct, and this is the value of the element. On the second struct, there's something to notice. It only prints A and 20, element A and its value. On the second struct, we actually have two elements, lowercase case A and uppercase A. As we know, lowercase element is actually not exported. So the thing to notice is that non-exported values are not marshaled by JSON Marshal. The other thing is we have an struct with a substruct. Here's a substruct, which is, and there it is. So those are the basics of marshalling elements in JSON with JSON Marshal. Now, an important thing to notice is that struct elements are actually printed in uppercase, since lowercase elements are not exported and not printed, as we saw with the lowercase a. But what if we want to actually have those elements in JSON to have a different name? To do that, we need to use JSON annotations. Let's do an example of that. It's example 3. In this case, we're going to have the following struct. It has a band, a song, a release date, a label, a chart position, and a producer. The annotation, as we see, is we simply have to use JSON and in quotes the name that we want it to be marshaled to. So when we print a band in JSON, it's going to be band in lowercase. Release date is going to be release _ date. We also see label. An important thing here is label has the option to be omit empty. This is kind of weird, but omit empty goes inside the quotes. And in the case of producer, we are setting this value, which is a minus sign. And in that case, it will always be omitted when marshalling. We're going to, on our function, this is our type, the type that we are going to marshal. And this is an instance of that type. We have a band, we have a song, we have a release date, which is a time, and we have a producer, which is William Orbit. Let's see what happens when we marshal this instance of the struct. Let's run the program. We are in example 3 of video 1 of section 3. First thing to notice is the ampersand was changed to a Unicode representation. Release date, which was a date, it's in readable format. Chart position has 0 value because we didn't add a chart position to our instance. So it takes the 0 value. But we did add a producer, yet producer is not there. Why is it not there? Because we have added the option omit if empty, which is omit empty. That's it for example 3. Let's go to example 4. In example 4, we have 2 structs. One is author. Let's see that the name will have to be marshaled as composer name with an underscore below. The same thing for last name. We have the same struct as we had before. The only thing we're doing is we're embedding an author. And our instance has an author whose name is Bob and last name is Dylan. And this is what we're trying to look at. Just seeing how struct embedding works. So we run the program in example 4, video 1 of section 3. Well, struct embedding work is just fine. The name came from the annotation. And pointers are the references. This is an important thing. Pointers are the references. Referenced. Here we're passing a pointer to author. That's it for example 4. So let's look at example 5. In example 5 and 6, we will be looking at a marshalling rather than marshalling. On example 5, what happens if we need to marshal JSON encoded string, or actually a slice of bytes, and we don't know the structure of this JSON? The thing we can do is we can use an empty interface, which we're here calling unc. And let's see at the JSON data. It's similar to the ones we have at the beginning on our first examples. We're going to have an integer 18, float 9.9098, string, an array, a substruct, and another substruct. Why is this a substruct? Because it's a substruct of the parent struct, which is defined by this sign. So we're going to unmarshal. To unmarshal, we need to pass a slice of bytes, which should be JSON encode, and a struct of some type. In this case, it's an empty interface. It takes an empty interface as parameter, and that's it. Then we're going to, the JSON elements that are found will be assigned to our unc variable. And then we're going to print what was assigned to the unc variable. Let's run the program. We are on example 5 of video 1 of section 3. This is interesting. The whole thing is a map, which means that what will be JavaScript objects are actually encoded as map when I'm marshaling to an empty interface. Substruct 2 is also a map. It's a map with an integer and an array. Integer is as integer, float is as float, the string is as float, and substruct is also a map. So what we see here is JavaScript objects this is how they are notated in JSON, are actually marshaled to a map, are resolved to a map when I'm marshaling to an empty interface. To solve this, to actually have structs be resolved as structs in Go, what we're going to do is we're going to actually pass as the second parameter to our marshal function an struct. In this case, we have the following struct, which we're calling myStruct. It has an int, a float, an array, a substruct, and a map. This is interesting. The first substruct we're going to marshal to a substruct, and the second one we're going to marshal to a map. And well, we're using JSON annotations so that integer will be mapped to int, float will be mapped to float, and substruct will be mapped to substruct, and substruct 2 will be mapped to this map. We're actually going to map here. So this is our JSON data. It's the same JSON data as before. And well, we are marshaling we have an instance of myStruct, and we're marshaling to that instance, and then we print it. This is example 6. Now, as we see, we have a pointer since the instance was a pointer. It's a pointer to myStruct. Here we're not printing JSON, we're printing the actual struct. This is a struct. As we see, integer in lowercase was mapped, integer here in our JSON data was mapped to int. The same thing happened to float, an array. Substruct, the first substruct is a Go struct, and the second substruct was mapped to a map as we determined on our JSON annotation and on the map type. Something really important is you should always use quotes for elements in your JSON annotations. I have run into a lot of problems when not using quotes. Sometimes it works, sometimes it doesn't, so always use quotes. And well, that should cover 99.99% of cases when you're using JSON. It's pretty simple. The only exception would be when you may have a loosely encoded JSON where a value may take different types. Now, this is horrible API design. You should never have a value that returns different types. You should never ever do this because it's complex to actually decode it. So if you serve that as a server, the clients will have problems. But in the case you are actually writing a client and you are decoding some external JSON that has this problem, you will have to write your own decoder. I'm adding a link that you can consult for these cases. Basically, it's this link. So if you have a problem like that, you should never do that when you're serving JSON, but it may happen when you're actually consuming JSON. This is a good resource. There's a link to this page on the videos README on the course repository.